Bright Tuty. Every student matters.
So let us have a brief of how we can measure time. So people, to measure time, there are various things to remember. If we have a clock, right? If we have a clock, we very usually or very casually tell anyone what is the time, how it is going. Is it 9 past 10 or it is 10:15? What is happening? Quarter past 15, 10, or what is going on? We can tell the time. But measuring time is not equivalent to telling time. Measuring time is talking about how much time has passed on since we have last seen the watch. So for example, I started seeing my motion at 10:10 and I saw my motion till 10:30. So how much time is elapsed between them? 10:30 to 10:10, what is the difference between is 20 minutes. So that 20 minutes is the time elapsed. This is measuring time and it is not similar to telling the time. So people, think about a scenario where you do not have a clock. How will you decide what time of the day it is? I guess we can still be very conscious about the sun's position. If we never had a clock in our lifetime, the sun still would be there, rising from the east in the daytime, getting over our head in the afternoon, then getting to the set, and the night is darker. So we can approximately tell what time or what duration of the day is going on. But if the clock wouldn't have been there, it would be very difficult. Now our elders would approximate time by using or looking at the shadows. So time has a history. We today use clocks and tell time very easily, but it was not the very start of reading time. Reading time even started as usual as looking at the sun's position too, measuring the shadows. So the shadow length changes over the day. By looking at the shadow, the time could be told. Now to measure the time interval, as I already told, the time, telling time to the time lapse, like how much time has passed, it's two different things. So how do we measure the time lapsed? How much time has passed by measuring it only when we can tell the speed. So when we talk about the time interval being a year, being a month, how we know? Our ancestor noticed that events in nature repeat. So if I have to tell it's a month, how will I get to know? The moon cycle. So the month was very particularly observed with the moon cycle. A month has passed. A year was the revolution of this earth around the sun. So we already have things in the nature which we used for telling time. But it is not very useful now because they were approximation, they were not final. The examples here are, which I have already told you, the sun rises every day in the morning and the time between the sunrise and the next sunrise was called a day. So already a definition of the day is defined here. The time between one sunrise and the next was called a day. Similarly, a month was measured from one new moon to the next, and a year was the fixed as the time taken by the earth to complete one revolution. So we here got all the definitions which our ancestors defined for us. A day, a month, and a year. So we have used nature over a very long time as our ancestors used to tell us. Often we need to measure the time intervals which are shorter. So if I do not have to measure the motion for a month or a day even, how will I get to know? So for much shorter times, clocks and watches came to our help. So clocks or watches are perhaps the most common time measuring devices which we know since the history of time. So we got to know that by the invention of these clocks and watches, we are now very apt in reading time. Now, how these clocks and watches actually measure time? Now, the working of clock is very complex because it's a mechanism. How one tool makes the other tool work or the other three tools can work together. So, it is about gears, it is about the mechanism going in. But all of them make use of one particular thing, that is, we are not going in the working, but we are going in the principle. That what is the principle of the working of the of the watches. How does a clock work? So people, they all follow one common thing. And what is that one common thing? Periodic motion. A clock is dependent on the periodic motion of its tool so that it can show us the time. Now, what is this periodic motion? Periodic motion are those motion which repeat itself in a fixed interval of time. So let's say anything that is moving, if the motion is repeated in a fixed interval of time, in a fixed interval of time, like it is going on and on and on. For example, we go school and every day we go to school. That is kind of a schedule or a regular thing we do. The simple periodic motion is also same. Okay, so once which is repeating itself over time is called periodic motion, and the biggest example of it is simple pendulum. So if I give you an example, let's see this pen. If it is being taken like this, it starts moving like this. This is called periodic motion, going on and on in this motion. This is what we call as periodic motion. So talking about all the clocks, the wall clock, the table clock, even the digital clock, they all use which motion? The periodic motion. So simple pendulum is nothing but a simple bob, that is a metal ball hanging with a string from a fixed support. When you disturb it, what happens? It starts executing simple oscillatory or periodic motion. What is oscillatory? The same to and fro motion. So what you see an pendulum doing is called the to and fro motion. It is periodic in nature and we call it oscillatory motion as well. Okay people, let's see what we have next. As I told you, it consists of a metallic ball or a piece of stone which we call as bob, and it is suspended by a rigid support with the help of a thread. So this is the very definition of a simple pendulum which can execute oscillatory or it can execute simple periodic motion in terms of that, right? Now, when we see the pendulum, the most common thing about a pendulum is it is hanging like this, right? So, it's my bob hanging with a hook like this here, right? Now, what is so cool about it? The point is this position is called the mean position, that is the center position of the pendulum to be resting. If I just take it like this and leave it, it will start executing the pendulum will be moving like a periodic motion. So it will keep going on and on and on. So the rest position is called what? The resting position of the simple pendulum is called mean position. When the bob is made to release, taken to a height, to one side, it begins to move to and fro, and this to and fro motion is what we call as oscillatory motion or periodic motion. So people, it is very important to understand the to and fro motion of the simple pendulum is the example of the periodic or the oscillatory motion, and all the clocks use the same periodic motion to work. So the pendulum is said to have completed one oscillation when the bob, starting from its mean position O, moves back to A and to B and back to O. So students, what does this mean? Let's draw this. Let's see, this is my pendulum and this is my position O. Once I take this pendulum here and release it, so this is my point A. The pendulum will come like this point, it will overshoot, go to point B and come back. So what is happening? From the mean position, the pendulum goes this side, comes back, goes overshoot, come back and O. So from O to A, from A to O, from O to B and B to O. So from the mean position, starting, coming back from one extreme and coming back from other extreme is making me one oscillation. So the pendulum also completes one oscillation when the bob meets. You can also say if it is moving from one extreme to the other extreme, that is also my one oscillation. For example, if I say I leave it from A, so from A to O to B, back to O and back to A is also my one oscillation. So these are the example of looking at what does one oscillation means. The one full to and fro motion is called one oscillation. So the time taken by the pendulum here, students, to complete one oscillation also has an important name, which is called the time period, and this is how our clocks work. With each periodic motion, we say, let's say a unit time has passed. So in this activity, let's see a simple pendulum as shown in the above figure with a thread and a string and for length 1 meter is attached. You have to switch off all the fans nearby. Let the bob be rested in its mean position. Once you see that it is started in its mean position, so everything is at rest, my bob is resting here in the mean position, and what you need to do, you need to see that what happens when you start looking at this. So when you are marking the mean position on the floor below this or on the behind the wall of the bob, you need to measure the time period. So what you will do? You will make the pendulum disturb it, take it to a point, start seeing that we're going that and coming back. How much time it is taking? You will see that the pendulum is approximately taking the same time. So if the stopwatch is not available, you can use a table clock or a wristwatch to do the same. But what is your task to do? Your task is to measure the time period of the pendulum, right? This way you will be able to set your own clock. So to set the pendulum in the motion, you have to hold the pendulum to one side and let it have to and fro motion. Make sure that the string attached to the bob is very tight and you can displace it. Now when you release the bob from the displaced position, you will see that the bob is starting considering the to and fro motion. Taking care that you are not pushing it, it is already handling or executing the to and fro motion on its own. So the time on the clock when the bob is at mean position, now that will be your time period. Now for more accuracy, do this experiment for 20 oscillations and then divide the 20 oscillations with the total time. So first observation, as you can see in the table, I will be showing you the table right away, is given. So time taken for first 20 oscillation is 42. Right, we have already given a length of the string. We are measuring what is the time period. So people, how will you calculate the time period? Let's see this. You need to record the observation for how much time it takes for 20 vibration. Right, your observation could be different from this obviously. You need to repeat this few times to make sure that your experiment is going right. Now what you need to do? By dividing the time taken for 20 oscillation by 20. So let's say it takes 42 seconds. Then you know these are 20 oscillations. Right? 20 oscillations. But we do not have to find 20 oscillations. We need to find what is the time period of one oscillation. That is one to and fro motion. So it will be 42 upon 20. That is around 2.1 second for one oscillation. Right? This is just for the accuracy. This is your time period of the pendulum when you divide it. Now you need to see that whether your time period is coming out to be same or nearly same in all the three cases. If there is a slight change, there might be the initial displacement is not accurate. So if there is a slight change, do not worry about it. Your initial displacement should not be affecting it, but it is important to understand that the changes may be there because you are conducting the experiment in an ideal or practical situation. Now clocks and watches which we use today are electric. We all know they run on batteries. But the clocks, they use a very special small pendulum in themselves, which is called a quartz crystal or a quartz clock. So the quartz crystal vibrate. It also vibrate in periodic motion. And the periodic motion of the quartz crystal is what is taken by the clock to tell you time. So the time measured by the quartz clock is much more accurate than the clocks available earlier. So here we understood that we can conduct this experiment 2-3 times and then we will be done with finding out what the time period of a simple pendulum.
To find time period of a simple pendulum. Materials required: metallic bob with hook, thread, stopwatch, blackboard chalk. Method: set up a simple pendulum such that length of the thread is about 1 meter. Switch off any fans as the moving air will affect the periodic motion of the pendulum. Mark the mean position of the pendulum with the help of a blackboard chalk. In order to set the pendulum in motion, gently pull it to the position B and hold it gently, making sure that string attached to it is taut. Gently release the pendulum from the position B. Do not push or pull the bob of the pendulum before releasing. Check that the pendulum performs a smooth oscillatory motion. Now take a stopwatch and bring it to 0 position. When the bob of the oscillating pendulum comes to position B, start the stopwatch. When the pendulum is on going to position C, again comes back to position B through A. It describes 1 oscillation. Go on counting the oscillations till the pendulum completes 10 oscillations. At this moment, stop the stopwatch and record the time for 10 oscillations. You find that in this case 10 oscillations take 20 seconds. Dividing the recorded time, that is 20 seconds by 10, you get time period for 1 oscillation, that is 2 seconds. Repeat the procedure 3 times. In the second case, you find that 10 oscillations take 19 seconds. Divide the recorded time, that is 19 seconds by 10. You get time period for 1 oscillation, that is 1.9 seconds. In the third case, you find that 10 oscillations take 21 seconds. Dividing the recorded time, that is 21 seconds by 10. You get time period for 1 oscillation, that is 2.1 seconds. Calculate the average time period by adding the recorded time periods, that is 2 seconds, 1.9 seconds and 2.1 seconds respectively. Now divide them by 3. You get average time period for 1 oscillation. Average time period for 1 oscillation equals 2 plus 1.9 plus 2.1 by 3 equals 2 seconds.
The units of the two quantities we have been talking about, the speed and the time. So it is very crucial to understand that when I am referring to a physical quantity, I always refer it using a unit. Now what does a unit specify? For example, if I ask you how much time it took you to reach your school, you may answer 10 seconds, 10 minutes or 10 hours. Depending on the unit of the time, I may be able to appreciate that the time taken by you is increasing. That is what the unit has in it. Same with the speed. If I talk my speed in units such as it is meter per second or kilometer per hour, I'll get to know how the speed is varying. So people, units are very, very crucial in defining and understanding the physical quantities. And here we are going to refer to two units. One is of time and the other is of speed. So let us begin with this. The basic unit of time. So the unit which we refer as the basic unit is called as a second. Its symbol is given as S. So the unit of time is second and we write it as a single letter S. But there are larger units as well. So as I said, as I've given you an example that you can take seconds, minutes or hours to do a task. The main difference will be you will get an idea of whether the time is increasing or decreasing according to your stuff. So minutes, the unit is M and hour is unit where you use H as the symbol. So these all are the units of time. Let's go to the further. Now we already know that these units must be related. Why? Because they are the units of the same quantity. They all are referred to same quantity here. So when they are referring to the same quantity, students, what it will be doing? They must have some relation in each other. So what will be the basic unit of speed? Before going to that, let me just give you what should be the relationship between the quantities here for time. So we know, students, 1 second is 1 by 60 of a minute, or to give you a better sense, 1 minute is given as 60 seconds. So there are 60 seconds in 1 minute. Second is 1 hour on the other hand is also equal to 60 minutes. So if I have to convert 1 hour into seconds, it will be multiplied by 60 and the answer will come out to be 3600 seconds. So 1 hour has 3600 seconds. So all of these are units of time. Hence, we can have a relationship between them. Now we come to the definition of defining the basic unit of speed. Now people, we already got to know that speed is equal to distance upon time, right? This is the formula that we have referred, that speed is given as distance upon time. Now when I write distance upon time, I already know my distance is measured in meters and I just got to know that the basic unit of time is seconds. So what do you think should be the unit of speed? The basic unit of speed comes out to be meter per second. Now of course it can also be expressed as what? We can also have units like meters per minute. Now why I write minute as MIN? Because M and N can be confusing. Or it can also have a unit of kilometer per hour. So as we have defined, there are various units of time, even various units of speed are even feasible. It only matters that whether you are measuring your distance in kilometer, your time in hour, or in meter, minute, or second. So as we define the distances and the time, speed being the formula distance upon time gives us the unit as meter per second, meter per minute, or kilometer per hour. Let's go and understand what do we do. Now you must remember the symbol of all units written in singularity. This is very crucial point. You never write kilometers as KMS. It is not something that will go as a plural word. You write it as kilometer. So what we write is 50 is itself telling me it is greater than 1, it is more than 1, it is more than singular. But your unit will not change to kilometers. Same with 8 centimeter, not 8 centimeters. So it is important to write. This is a very noteworthy point, people, here, that we should not miss on this. We generally make this mistake. Second thing, if you can note here, is that K, C, all the units starts with this is singular. It is written in smaller letter. But eventually you will get to know there are some units we have to go with singular letters and there are some which we go with the capital letters. So let's bring in Buju now, who has a question. So Buju is wondering how many seconds are there in a day. Now this is super intelligent question that Buju is asking. I have already given you the unit of time is seconds, right? In 1 minute it is 60 seconds. In 1 hour, it is 60 into 60, that is 3600 seconds. Now next Bojo is want to know how much in a day it is. So in a day there are 24 hours into 60 minutes into 60 seconds will give me the total answer. So 24 into 3600 will be the amount of seconds in our day. So if I need to just calculate it, people, if I just calculate this, people, this comes out to be 86,400 seconds. So in a single day, there are these many. If they want to ask how many hours there are in a year, so in a year, there are 365 days into 24 hours in every day. What do we get it, pair? So 365 into 24, people, we get to see. So if I need to calculate how much is 365 into 24, it comes out to be 8,760 hours. So people, this is like we can calculate for time as big or as small we are calculating as. Let's go to the next thing and let's understand what is it. There is a very interesting story about the discovery of the time period. Why a given pendulum is constant. So people, when we did the experiment with the pendulum, we got to say that the pendulum goes like this, comes back and goes like this and comes back to give me one oscillation, and the time period taken for one oscillation is one time period. That is what is the time period, the time taken for completing one oscillation. Now when I say this one oscillation, now it doesn't matter that whether my pendulum goes from here to here, or if I want to just see that things changes or not, I just make the pendulum go till this point. The time period to complete one oscillation is always same. This is the discovery. This was the very interesting discovery, that the time period of a given pendulum is constant. Doesn't matter you make the pendulum go farther apart or you make the pendulum go nearer. The pendulum time period for completing one oscillation for, let's say, T1, let's say this is T2, let's say this is T3, each one of them is equal irrespective of how much you displace the pendulum from its place. So this discovery was made by the very famous scientist we already know as Galileo Galilei. He used to live in the AD 1564 to 1642. It is said that once Galileo was sitting in a church, and what did he saw? He saw the church bell doing the to and fro motion. So he started looking at the lamp suspended from the ceiling with a chain which was moving slowly from one side to another. So if it is going like slowly like this is executing the to and fro motion. He was surprised to find that his pulse beat the same number of times during the interval which the lamp was completing one oscillation. It was this time, students, that he was able to figure out that how the lamp is going to and fro, the same time he is able to match with his pulse. Now doesn't matter it start moving faster or slower, it was always taking the same time to complete one oscillation. So it was a very big discovery made by him, that the same time of interval was taken by the lamp to complete one oscillation. Now, Galileo experimented with various pendulums to verify this observation. A lot of experiments he did. He found that the pendulum of a given length takes always the same time. So, this was his observation, that a pendulum of a given length always takes the same time to complete one oscillation, irrespective of how much you disturb it. This observation led to the development of the pendulum clocks, and here we are now using not the pendulum but a similar phenomena using a quartz crystal to actually read time with our clocks. So winding the clocks or the wristwatches were the refinements of the pendulum clocks. So very initial stage of clocks were using the pendulums. Now they are being gone to minimizing by using the same kind of phenomena but using a crystal which vibrate at a constant frequency or in a constant time period. Right, people? Now different units of time are used depending on the need. As I've already told you, the units can be minutes, seconds, hour, right? But we use it according to what we are referring to. Now, if you are expressing your age, you know it would be smarter to say that I am 13 years old, irrespective of saying that how many days or how many hours I have been living for. That will be really a fun way of telling this, but it will be very, very confusing. Similarly, it's not wise to express the years in time taken for you to cover the distance between your home and your school. So if you're going to your school, you will not say I took 1.5 years. You will not say that. You will not say I'll take 0.11110 years. That will not be the convenient or the wise way to say it. It would be more of a teasing way of telling someone how much time or you are taking to go to school, right? But what is the right way of saying that? The right way of saying that yes, it took me 10 minutes or let's say half an hour. And for your years, for your age, years is a better of unit, a better way of telling the unit of time. So it doesn't mean any unit is wrong or right. It is just about situational or conditional which you need to go for, right? Now, how small or large is the time interval of 1 second? This is the next question. Now, how big is 1 second, students? This is where we are going to define 1 second. The time taken in saying aloud 2001 is nearby 1 second. So that is a very cool way of remembering what is this. So the time taken to loud say that 2001 is 1 second. 2001, another second. 2001, another second. So it is nearby equal to 1 second. Obviously, you do not have to go 2001. You have to go with your normal pace. It will be approximately giving you how much is 1 second. So verify it by counting aloud from 2001 to 2002 and 10. So you can just see, even if you want to count from 2001 to 10, your pulse is going to give you 1 second. Now the people who actually measure their pulses, they get to know that the pulse of the normal healthy adult at rest beats around 72 times in a minute. That is about 12 times in 10 seconds. So in a minute, if it is beating like 72 times, so you can take in 10 seconds, it must beat around 12 times. This rate may be slightly higher for the children. So there are various ways in which we can roughly tell how much 1 second is equal to. Right, people? We can tell this by looking at the pulse rate or saying 2001. So Paheli now here is wondering something. And what is she wondering? She is wondering how time was measured when pendulum clocks were not available. So people, as I told you, there were many time measuring devices even before the use of the pendulum. So before the pendulum clocks became popular, sundials, water clocks, and even sand clocks. So even today we use the sand clock in the board games, right? You get 1 minute or 2 minutes to solve a puzzle. So sand clocks were those. There were water clocks, sundials, which are still used. Even Newton was so famous of using sundials. Sundials use the power of sun and the shadow to tell the time. These were the examples for time measuring devices before the advent or before the pendulum clocks got popular. There were different designs of these devices around the world. So as the place was changing, the design was also changing. But these were the basic kind of clocks that were used in the ancestral time. So these are the ancient clocks that we used to read time earlier, right?